Hi, everyone. Thanks for coming over. Big thanks to organizers for organizing this meetup. Let's all give them a big round of applause. All right, we're going to talk about serverless microservices. You probably heard about those two terms, but we're going to put them together, make the magic happen, and get to the bottom of what it is. Couple words about myself. I'm Alex Tamoykin. I'm from Russia. Been coding since Figurative Elementary School, got my degree there, moved over here, started working with startups. Currently, I'm co-founder, CTO at Shuttle Finance. We are an automated savings app. I'm also founder and CTO of The Right Balance. We are a software consultancy. We help growth companies to do things right, to scale the team and the product. So if you're bored at your job or you want to get something done right, give me a call. All right, so we're going to talk about three things. We're going to talk about why serverless microservices are important, what those things are, and how you can go about implementing that on your project. So with that, first of all, let's start with why. So from all of you, if you remember deploying your app to a physical server, raise their hand. Oh my goodness, there's quite a lot of people. So if you remember, this is a pain in the neck. You got to go in there and get to that box and plug in wires. And sometimes the bugs go bad, so you got to open the closet and hit that restart button. So in dealing with services, something takes a lot of time. As an engineer, you want to apply your precious time towards something where you make the most difference, which is writing business logic. So second thing, that scaling servers is hard and quite expensive. Imagine you have, who's got EC2 machines running? All right, here we go. So servers are there, they are running, and you pay for them. So if you have multiple environments, that adds up, especially when this whole thing is running, during the night, you're still paying for it. And it's you got to keep an eye on how many servers you're running, so your AWS bill is adequate. So it's it's expensive. And the third point is that Monolith doesn't scale. So I've done a lot of Ruby on Rails. Great technology. Like first time I tried that out, I was blown away how fast you can get the website up and running. It was amazing. However, with any of the monolith technologies, Ruby on Rails, Laravel, or any other similar tech, Django and Python, you get to a state where you develop something like this, which is a single big app that basically have all those different services jumbled together. There are problems with that. It's hard to scale that. The only thing you can do with the Monolith app is to make copies of this, deploy it onto different machines, scale horizontally. But that comes back to the point number one, number two in this case, which is those servers get bigger and they get more expensive. So what do we do with this? That's where comes in serverless, the tech that allows you to forget about servers altogether. Now you just deploy your code and let your service provider to handle this stuff for you. There are still servers. So it's not magic. It's like there are still servers out there and they spawn up and they do the work, but you don't need to worry about them. And the second thing is microservices is where you split that monolithic app into small services that talk to each other instead of having one big monolithic application. So how did we come here? We started first with physical servers. At some point, public cloud came out where we had EC2, virtualization, and things like that. And now the latest evolution of our deployment is functions. So AWS has Lambda, which is their implementation of serverless. Azure from Microsoft has functions. Google Cloud has cloud functions, and Twilio also has functions. So they have things where you deploy the code that actually is not running on your machine; it runs out there. As far as I understand, is that true? You guys have that? Okay, confirmed. All right. So so what is serverless? Serverless, three major things. First, no servers to manage. So you deploy your code, you forget about servers altogether. It spawns up as many containers as you want. It's infinitely scalable, and which leads me to the second point, which is auto-scaling out of the box. You don't need to worry about scaling, right? So today you have one request, tomorrow you have more requests. This whole thing, scales with that demand. Of course, there's things to deal with. It's not like silver bullet, but one thing is it's less headache on that front. Third thing is pay per request. So you don't pay if you have no traffic. So servers are down with serverless, you pay nothing. Whereas if you have EC2 boxes running, if it happens through the night, you still pay for it. So, and microservices is basically where you break down this big monolithic application to smaller services that talk to each other. That gives you three main advantages. First, it helps you with parallelization of your work. You can have multiple people basically working on different microservices, whereas there's only so many people you can fit in a single repo before they keep running into conflicts. Second thing, it helps with scaling because you can scale every individual service individually instead of scaling the whole thing up. And the third thing, it is just faster because services are smaller, it's faster to deploy it, it's faster to implement changes, you find defects quicker, and you're overall more productive. All right, and serverless microservices is where both of those things come together, and now magic happens, and you get the best of both worlds. At the end of the day, that's what this whole thing is about. It's serverless microservices come together, and it's awesome. All right, so how are we going to do this? Real simple. It all comes down to writing your handlers. So every function has a handler, which is a function. You get event, context, and callback. You do what your function needs to do, create users or send emails or whatever it needs to do. And then you construct your response. You set your status code, body, and then you call it callback. So with callback, first parameter is your error if thing is unsuccessful. Second is your response. And if the first one is null, that means it's success. If first one is not null, that means it's failure. So you have to call that callback. If you don't do that, then your Lambda assumes that it is running and there's work to do, whereas there's no work to do, it will time out and you'll be sad. So what you want to do, you want to call that callback function to make sure that things are golden and everything's all right. So now that you got your function, you upload it to, in our case, AWS. Then AWS makes it really easy to create different triggers. So Lambda can be executed from API gateway through HTTP request. It could be triggered by an S3 file upload from Dynamo when things are inserted, or even from SNS, from other Lambdas coming in. So now that you basically go to the Lambda interface and drag and drop those things, you have your Lambda actually working for you in reality. And that's what it comes down to, serverless framework. So not to confuse with serverless tech. So it's basically a framework that is named with the same name as the tech itself. What it does, it automates a lot of this stuff. So you don't need to then create your functions and then for every function plug it in and then do the same thing for your stage environment, for your production environment. So that's what serverless does. It allows you to put together a stack and basically make it all once, and then with one command, you basically just deploy it. So serverless framework, the main thing about it is the serverless YAML file. So in serverless YAML file, you create your functions, you describe what those functions are, what the handler is, how it gets triggered, different parameters for it, environment variables, things like that. Serverless also has a lot of plugins. So one of the really useful ones is called split stack, because what happens under the hood, once you run this awesome command that just deploys your function to AWS, it packages it up in a zip, creates a CloudFormation template, puts it all together, and uploads it to AWS. So in other words, there's a limitation for how big CloudFormation stacks can be. So the serverless split stack plugin allows you to split your stack so you can deploy more stuff. So point here is that serverless has a lot of different plugins, community around it. It's a great technology to explore. So with this approach, you get to serverless microservices. And with serverless microservices, instead of having one single app, you now have multiple Lambdas that can be connected, over HTTP, and different requests might go to different places. So also you can have your Lambdas talking to a database, whether this is DynamoDB, Postgres, or any other database. It might talk to the database. Your Lambda might not talk to the database, might do something completely different. You can trigger those things from an S3 file upload. Your Lambda can also talk to S3 on its own. Your Lambda can send emails, and every single Lambda does its own thing, just one thing. That's the whole point of it. And each Lambda can talk to each other through SNS. So with this, at the end of the day, you get a pretty powerful architecture with a lot of those building blocks where you can put it all together and create something really amazing. So that also follows a principle of Unix philosophy is based on the same principle where you have small pieces of software that do one thing but do it well. So that's the same idea here applied on the back end in the microservices world. Of course, it's not silver bullet. There are gotchas there. So we have gotchas. So gotchas are the following. There are following gotchas. So first of all, function execution is capped at 5 minutes. That means that your Lambda function can only run for 5 minutes. If you are still in the mindset of collecting all the data through the day and write a nightly job that kind of goes through it all, you got to stop doing this, because this is not the tool for that kind of thing. So functions, especially serverless functions, they are all about events. So you got to start thinking about how to handle those things as they happen. And you will end up in a better place because your system will be processing things like that. And this will happen in real time as opposed to waiting through the night and running that job. And running jobs is also not a very scalable solution either. Functions cannot hold state. If you got used to writing a file, that's not going to work, because it's all running inside containers. You have one request coming in. The second request comes in into another box. That file is on the box from the previous request, and it's not working. So you need to save your data in the database S3, something where it persists. Warm-up times is also a problem. The first time request hits your Lambda, it takes a while to warm it up and spin up that environment. Subsequent requests come in, and they're processed very fast. So the way to deal with that is for all this stuff that has to be available in real time, you set up triggers. Right? So you just hit your Lambda, keep it warm, and Lambda is warm. Right? For stuff that doesn't have to be real time, it can stay cold, and that will be cheaper. So deployment package has its limits. So there are limits on how big your individual Lambda can be. So if you package a lot of stuff in there, that cannot go forever. So there's a different limit. I don't remember off the top of my head, but I think it's over 100 megabytes for uploading a Lambda from a web interface, and it's about 7-ish if you upload it from the API. So just make sure that you slim things down. There are also plugins there that basically take this whole Lambda and compress it and all this cool stuff. And at the end of the day, you got to try catch your exceptions yourself in that environment. Because you got to react on those exceptions yourself and do reporting and call that callback with the error to indicate that your Lambda actually failed, and you can react on that. You can just, in that environment, you cannot rely on things just blowing up and automatically doing the right thing. You got to handle your exceptions yourself. What I usually do, I wrap the whole entire function inside the try-catch itself, and if something bubbles up, I grab that and I shoot it to Slack, CloudWatch, or anything like that. All right, so that's pretty much it. I want to leave you with one thought, which is the software that we're building. We build it for people, and our users are they demand more. every single day. They want stuff to be real time. They want stuff to be fast. They want, like our products have more and more demand as we go along. So with that, we can't really keep doing what used to work and just sticking with this. We got to break through the limits and iterate and innovate, and that requires some dedication, trial and error. But at the end of the day, you'll end up in a better spot. So I encourage you to come in tomorrow to your project, look at what you do, and figure out what you can do better. Just rethink what you've done before and whether or not you can innovate, right? That requires iteration and hard dedication, but that's what needs to happen in order to innovate. All right, so thank you for your time. I'm Alex Tamoykin. AlexTamoykin.com is my blog.
All right, who has a question? Got a question right over here. Wait, you're not going to throw it?
Testing. Do you have any recommended strategies for managing multiple environments like dev, staging, prod?
Yeah, so Lambda has a solution, but that solution is not that great. So Lambdas have versions and have what is called aliases. So you are able to create an alias that points to a specific version of your Lambda, and that's how you can implement multiple environments. So you can have one set of Lambdas responsible for dev environment, one set of Lambdas responsible for staging environment and production. I tried it before, and that ends up being hairy. And at the end of the day, what I ended up doing is creating multiple AWS accounts for each environment. So you basically have one account, one set of keys, and that thing, it just doesn't talk to anything outside of that account. Of course, you need to put things in the VPC so it doesn't go out. But for me, what ended up working best. Yeah.
It's more secure too.
Exactly. Yeah.
I'm aware of like
Just toss it.
Node Lambda, which helps to test locally. You can do like Node Lambda run and run your handler function locally and see that it works.
I'm gonna hold it here.
Yeah. So the question was,
Are there any other serverless I've not heard of, but are there any other local testing strategies that you would employ?
So before serverless came about, I've used, I think, Node Lambda, actually. That's what I've used before. So before serverless, that's what I've been using. And that thing deploys to AWS, helps you to run it locally and test your stuff locally, plus writing unit tests for it. There's Node Lambda, which is great. So there's also AWS local. So basically, AWS itself has a command line tool that also allows you to do that. What I found is that serverless has better support and a lot more tools available out of the box. So that's why right now I'm using serverless. But to your point, I've used Node Lambda before, and it's great. There's also AWS package that does the same.
And to the previous question, they also have a .env file when you're using Node Lambda that you can declare the environment that you're testing. And when you deploy with that, it suffixes the name of your function with the environment. Still not a great solution, but that was another one.
Yeah, so it puts the dash environment name in your Lambda name, and what you can do in your API gateway, once you plug in your Lambdas in there, you can say kind of map all Lambdas with dash production into the stage production, and that way you can implement multiple environments in the same account. So which is also pretty great.
All right, any other questions? Last one. Nice.
So how do you feel this?
You gotta talk into the box.
So how do you feel?
That works. Okay, good.
How do you feel this integrates with the 12-step process for Heroku? That sort of 12-step.
12-factor.
12-factor apps. There's a whole entire article on that. I don't remember off the top of my head all of the factors that need to go in it. So I guess your question is, can you deploy Lambda on Heroku? Is that what you mean?
Heroku. I'm just wondering, like, you touched on this for the configuration with the last question for like environment variables and stuff like that, where you would normally have that set up for the server, you can't really SSH into these, right? You set them up.
You cannot SSH into box, so you have some control over that. So I don't remember all the requirements for the 12 app, the factor app, but I do have a blog post bookmarked, so I'll share that with you. And there's literally a whole entire thing about how to make it 12-factor compliant. So there is a way to do that.
Cool.
All right, everybody give it up for Alex.
Thank you.